switching in Fortinet is meant to be simple, intelligent, and security-driven above all. So with the FortiLink technology, the FortiSwitch is easily managed by the FortiGate and becomes an extension to the security fabric. And so that means securing each single port that you have there in your fabric. So with that in mind, I'm going to start my demo by onboarding another switch. So I have here on the side one switch that is not connected. So I'm going to just clean up all the config here. So reset it to factory. And then it will come back up and be discovered and join this security fabric. So while it's doing that, I will show you here what I have in this topology so far. So this is basically, we have 3 access switches. So I'm showing now access 2. It's a FortiSwitch multi-gig 426E. And then we have 2 others here. So 448DP. And so looking at the topology, we have here, they are dual home to the core. So one uplink to each of the core switches. And here at the core, we have then a pair of switches. So they are acting as MCLAG peer group. And this different link here that we see between them is the ICL, so the control link that is with 2 physical cables, no? So 2 physical links there, port 49 and port 50. And they are making sure that we have not only the link redundancy, but also the switch redundancy for those access switches, right? And here we have the FortiLink, so the link towards the FortiGate, which is the controller, which is where also all the security is applied, or I mean the policies are there. And we see that from the FortiGate, we have we have actually here a FortiGate active passive, so doing HA. And then we can see from each of the units, we have a link towards the MCLAG peer group. So while I was doing that, we saw that the other switch popped up here. So it's being discovered. I'm going to give it a name. So this will be our access 1. And also I'm going to just move it up so we can have good representation here from top to bottom based on the numbers. And I'm also going to add it to a group so we can, group it any way possible. So I have, in this case, 2 different sites. So this access 1 also belongs to site 1. So we have core, site 1, and site 2. So back at the topology, we see that now the switch is online. So we have the onboarding done. Next step is we have to assign the VLANs, right? We have to start providing connectivity there. So we do that with the FortiSwitch VLANs. They are basically another layer 3 interface on the FortiGate. So you can treat it as another interface on the FortiGate. And I'm going to show you here the VLAN corporate as an example. So then in this case, we have the VLAN ID, of course, and other properties from the FortiGate interfaces. And we have the IP address for the layer 3 connectivity. And it's also with the HCP server enabled. And we have some other network properties here. So device detection is one of them that is very important for us to see all the policies in place. And another example here is the public interface, or FortiSwitch VLAN. In this case, it's meant to have more open access, but at the same time, I want to have more protection. So I enable the GMP snooping, DHCP snooping, and the block intra-VLAN traffic. So that's basically an option to avoid any host-to-host communication. So we can make sure that any traffic, even within the same VLAN, has to be secured by the FortiGate. So once we have the VLANs defined, so we can go and assign them to the ports. Let's take this new switch that was onboarded. So I can select a few ports here as the example. So I'll also select the first port, and even select ports from others switches that are already there. And I'm going to assign the VLAN corporate in this case. And then also here on port 15, I'm going to assign also VLAN public, because we have clients there. So let's go and check that those clients can connect. So we have client here, C Maria. I'm going to enable the interface and make sure that it has access. So we can check here that it has an IP address. So I'm going to open the browser and check some sites on the internet. So just to confirm it has connectivity. And I'll do the same for the other client. So here it's I have to enable the interface. Then we can check if it has an IP address. So yeah, it has IP address. Let's quickly check connectivity. Also here we have the browser. So let's refresh the site. That is also taking part in the device detection. Also that, but okay, let's go back now. We see that they have access. And let's now check. So the question: how did they get access to internet? Because it's allowed by the FortiGate. There is a policy there that is allowing those devices to connect. And for the corporate VLAN, this is the policy that I'm using: corporate to internet, and using here the application control. And the application control is the layer 7 visibility. So the layer 7 power that is provided by the FortiGate to look at every application that endpoint is reaching or running. And this gives us very granular control of how that device is connecting, what is allowed, what is not allowed, and so on.
Rafael, I've got a few questions around this solution. First off, around management. It looks like you're on a specific firewall and you're configuring both the firewall and specific switches. Is that the best practice from a Fortinet standpoint for managing? Is you use your centralized firewalls to manage the entire campus, or is there some sort of an outside controller or VM outside of that that's doing that management, or are we doing this all from a set of firewalls?
Yes, yeah, I'm using here one showing you one fabric, so one FortiGate but this fabric can contain multiple FortiGates, right? And then in that case, we can use our management solution with FortiManager. Then with FortiManager, we can expand to multiple FortiGates and then push the configuration from there to multiple switches. And as James was saying, in the case, for example, of the SD branch, you have thousands of sites. They all contact FortiManager, and they get their configuration all from that single point.
Okay, so from a use case perspective, let's say I run a centralized network where all of my remote sites connect up through a data center, and I have data center firewalls out to the internet. Would a customer in that scenario, would they leverage those firewalls to configure their remote sites, or would they leverage FortiManager?
Typically, they would leverage FortiManager,
Okay.
right? FortiManager, when you look at it, FortiManager is there so you get visibility into all of the firewalls that may be in your network.
Okay.
So really, it depends on the size of the deployment, right? For some of the smaller deployments, perhaps you would be doing exactly what Raphael is doing,
Okay.
and be going directly through the FortiGate. But then once you get beyond a certain size, you don't want to have to log into 5 different FortiGates just to be able to make a change or deploy or do something along those lines. And that's where FortiManager really adds in a lot of value, because I can, as Raphael points out, push out configs and be able to manage both my data center as well as my branches and so on and so forth for one place, and be able to have it confirm all the policies that are in all the remote as well as the data center.
And is that FortiManager on-prem or in the cloud, or either one?
It can be either.
Okay.
Right. It's on-prem or in the cloud. Typically, you'll see it on-prem, but it's also in the cloud.
Okay.
So FortiManager is kind of the manager of managers.
It's the manager of the FortiGates, right? So yeah, you can kind of think of it as the manager of managers, but really when you're talking about it from a FortiOS perspective, you can manage everything as you're seeing in this demonstration through FortiOS, but the FortiManager is the most effective way of you being able to manage the solution at scale.
FortiOS is the software which we have been developing and converging, which runs on FortiGate. Parallelly, we have been developing FortiManager to manage all of those capabilities. So every time we introduce a new feature or capability, like how we did with LAN, WAN, 5G, everything can be managed from FortiManager. But sometimes we show this through FortiGate because it shows you the power of how we extend the security. It's not just the control plane managing from FortiGate to managed switch, it is also sending you the security policies there. So those are the benefits. So yes, customers often start with FortiGate to FortiSwitch, but as the scale continues, they always have flexibility to go to FortiManager and do it at scale.
Can we take that conversation one step further?
Sure.
Do you offer programmatic API access to FortiManager or the individual devices? So if someone wanted to automate or build scripts or do things
Absolutely. That's been the big portion. In fact, everything that we build in OS, any CLI, it has API availability.
That's true at FortiManager as well.
FortiManager as well.
Top level.
Correct. And that expands because now we have over 500 plus partners who actually leverages.
Okay.
So FortiManager is integrated into many products, whether it's cloud, whether it's Tufin, or many products to make sure that API-based thing is being provided to them as well.
Full parity.
Full parity, absolutely.
And documentation?
Absolutely,
Okay.
yeah. And these are the products. FortiOS, FortiManager are the foundation for Fortinet for last 20 years, right? So these are absolutely important. Thank you.
Excellent, thank you.
I also have a question, and I might be going back a little bit. Can you unpack exactly how the auto discovery works? Is it just something proprietary where the FortiSwitch is blasting out some custom packets that other Forti devices will understand and link them into the system?
That's very
Yes, so when the switch is connected, they will exchange information between each other, right? Then create the inter-switch links. And from there, that switch can announce itself to the FortiGate, and then the FortiGate can establish the connection and take control of that switch.
And is that initial traffic for auto discovery, is that secured? Is that encrypted? How is that encrypted? Is it using TLS? What certificates does it accept?
Yes,
You can unpack that.
Yes, it's encrypted. So it's using the CAPWAP protocol, which is standard. and after that, it's using the API. So it will, everything is encrypted. Yeah.
I don't want to derail this conversation because it's been a lot about configuration and kind of the onboarding. Are we going to get into like the actual switch architecture? I see MC lag up there. I have some questions about how that works. I want to talk about, you know, those access. Can you stack them, or what does that architecture look like? Are we going to get to that in this presentation, or should I ask that now?
You can ask now.
Okay, so let's do that now. So let's start with MC lag, because this is a point of pain. I think everyone sitting around this table has probably at one time or another dealt with challenges around multi-chassis aggregation. So can you explain a bit? I don't need it super deep, but I want understanding about what's your approach to that architecture, because there's several ways to do it.
Yes, I will explain. So basically, we use two switches to act as one. So in terms of visibility to other switches. In the case of the access switches there, for example, let's look at the first one. It's one link, a physical link to each MCLAG peer, but the link aggregation that we see here is is logically to one single switch, right? So it means that we can have both links here are active, and I mean, forwarding traffic, and the access switch sees the core as just one link aggregation group. So it will provide the redundancy in terms of the link, right? If the link goes down, you have another uplink, but also on the core side, we have the redundancy of the switch itself. So if that switch goes down, the other link is still working via the other switch.
Sure, I understand the intent. I guess what I'm asking is, what does state look like on that core? Is the state on a single switch, like there's a single controller and the other one acts as like just a dummy line card extension? Are they both maintaining state? Like, how does that look? Because I mean, like I said, there's several different approaches to that MC lag that you have up there, and I'd really like to understand how that is, because it's super important.
Yeah, I would like to also ask on top of that, if assuming there will be control plane synchronization, it's going to happen through a controller? Is it going to happen through a direct link? In which way do you provide this control plane state so that one switch knows that the other one is part of the group, and whenever the link is down, then the takeover would be seamless?
Yes, they are independent switches, and they work together via the ICL link, which is this one in blue that I'm showing here between them. So over this link, there is the exchange of information, state information, so MAC address synchronization and other things, so that they know about all the changes around them.
And as far as those two switches in that lag, do you support minimal downtime software upgrades, or do you have to take down both at the same time?
No, you can upgrade one at a time. There will be some slight glitch, interruption when one is going to join the network again, or reboot because of the software upgrade, but then it will be minimal. That's usually how it is. Yeah.
Yeah, just want to add on the upgrade part, right? So in this architecture, from switch controller perspective, we also support stage upgrades. So for example, all the images, right, for all the switches are downloaded, saved, and then you can actually, there are many where you can choose how you want to reset everything. So reset will essentially get the next new image. So stage upgrade is actually, we see it's pretty popular. We use it in our own, like James mentioned, we have our own switches and our IT infrastructure, and we see a lot of customers find it useful also. Going quickly back to earlier question of MC lag, I think the question was how it is seen from one place. Like for example, from this menu on switch controller side, you have visibility to all MC lag cores and all MC lags, right? So you can actually see everything from one place. I also want to add this setup does not have it, but it is scalable in the sense that this shows 2 tiers. It can actually be 3 tiers also. So that way you can kind of expand and have fairly large network.
I think we're deviating from the what, and we were asking actually the how. We understand that MLAC is a well, in a way that you implement redundancies so that then there is resilience after a failure. But how did you implement the redundancy was the initial question. Is there a link between them, or is it a control plane synchronization, or is it both devices, as in a stack, for instance, in which there is a single control plane that has 2 devices simply available to it in a physical way, or how is the group of firewalls then ensuring that they actually have a hive mind and they can take over one over another and not produce then even in a minimal outage, because the goal of having them is that they will be seamless then takeover.
Yeah, I think how part, as Rafael mentioned, yes, there is link between two, right? So standard like MSLAG, ICL is fairly standard term, you probably are familiar with. And there is control plane synchronization. There is 2 management planes, right? So 2 switches are independently managed, but there is control plane synchronization. So we support,
I want to push to the edge side, and probably a simpler question. Do you support stacking in your access switches? Because I see 2 links, but I see 1 switch. Every implementation here is a single switch. Can I have a closet full of 4 switches that stack together that I link back in aggregate to the core, or is it every switch needs to have links back?
Yeah, so what we have is what we refer to FortiLink stacking, which is slightly different than what maybe general industry term. But yes, you can have a stack of 4 switches, let's say as an example. Well, in other words, let's say you have this core and each of these switch can be actually 4 switches stacked and 2 links, let's say from top switch and bottom switch going to your MCLAC core.
So you can't have stacks, 4 switches is your, okay.
Yeah, in this FortiLink architecture, yes. Yeah.
Can I ask a slightly different question? So understanding a lot of the, at the beginning you spoke about the need for simplicity, and certainly the user interface here and some of the intelligence and provisioning is clear. There's often a trade-off that if we want the simplification, we're going to be more prescriptive in how you can deploy. And here we're seeing a kind of layer 2 access topology. You said it could go to 3 tier. Is there complete flexibility for the customer in how they can deploy this? Could they go, for example, to routed access with ECMP to spine switches, or could they do a VXLAN fabric? Or are you being fairly prescriptive, assuming this is a smaller branch deployment?
Yeah, so not yet. Not yet, yeah.
You were showing us configuration through the FortiGate firewall to that switch, and you were showing us the manual configuration of a VLAN. Do you have that? Can you walk us through that dynamic authorization that you can use through FortiAuthenticator or an external radius solution to dynamically configure that port in a VLAN and with any other sort of security enforcement when that device or user plugs in?
Yes. I have that as part of the demo as well.
Okay.
So just quickly wanted to resume from the client perspective here to show the device information. So the visibility that you have here of what is connected. So we see that client is detected, and we see the information of that client, not only the MAC address, but we see all the relevant information that is coming from the device detection. And if you have here an easy button to quarantine the host. So if there is a requirement to do it manually, you can do it here. But if that host is doing any malicious activity in the fabric, you can use automation to have it done automatically. So that is part of the security fabric automation functionality.
Hey, Rafael,
yes.
where is that identification done? Does the switch do that, looking at traffic as it goes by?
the identification of the device
Yes.
is done on the FortiGate.
On the FortiGate,
is
okay.
acting here as the sorry, go ahead.
On the FortiGate, not on the switch itself?
The FortiSwitch is sharing information of what is connecting, right? The MAC address or maybe LLDP information, depending on what is connecting. And then the FortiGate will eventually do the complete identifications. And that includes if one of the FortiGuard serves is the IoT device detection. So you can basically plug any device, and if the FortiGate eventually cannot identify it, it will use the intelligence coming from FortiGuard, and then we'll be able to identify almost all devices.
Okay.
Yeah, so all the profiling functionality is actually on the gate.
Yeah.
And then if it, just like you said, if it doesn't know it, it will go out and utilize our IoT FortiGuard service.
So you're not leveraging the FortiAuthenticator to do that profiling?
For the NAC functionality from an IoT perspective.
Oh, okay.
Right, because you know how it goes. It's more than 60% of devices are headless.
Yes. So once again, so it's clear, because maybe I just missed it. So whenever you do the recognition, is there any DPI engine or anything sitting into the box, or does it have to go all the way up to FortiGate and then back?
All the policy and everything else is utilized through the FortiGate. And Sandeep, I don't know if you want to add to that.
Yeah, you can see FortiGate as the decision maker at the end, but it is consolidating the information. So switch does play its role in sending information to FortiGate. Like what Rafael mentioned earlier, some of the LLDP information, there are features which we can enable where it will send more information from even DSCP, fingerprinting, and things like that. Now, especially when there are devices, let's say they're talking L2 within a VLAN for a while, and some there are, let's say, aging out and things like that. So we didn't want to miss that information or those devices. So for it is very important for switch to send what it knows to FortiGate. So it is consolidating. So FortiGate is consolidating information finally to identify the device. So switch plays its part there.
To put it in another way, then it means that for some operations, then the switch is going to handle them. But for some others that require a more informed decision, then it will have to go all the way up to FortiGate and then back. Is that right?
Yes. Rather than saying like there are two different classes, it is more like device detection is at the end done by FortiGate, but it has information collected from switch also.
So FortiGate would be similar or akin to a top of rack switch, and then the FortiSwitch is just gonna do just the handling of the packets back and forth or frames.
Well, they're forwarding, but they're sending the information about what it sees to the FortiGate or switch controller.
Understood.
Yeah.
Okay, thank you.
Thanks.
So are the switches capable of running without the FortiGate if it's always interacting with the FortiGate?
So in this deployment, FortiLink, right, it is FortiGate is always there. But just if your question is, can someone use FortiSwitch independently? Yes. Obviously, the things that Rafael is demonstrating here, those will not be applicable in that case, because this is more of a demo of our integrated security fabric with LAN edge demo. But yes, switches can be used independently. We have LAN cloud management for those also. Yeah.
Yeah, then I'm going to switch now to the FortiLink NAC. So we talked about just assigning a VLAN to a port, and now I'm going to talk about really the very granular control of what is connecting to that port, and dynamically checking that and making sure that that device, that endpoint, is assigned to the right resources. So the right VLAN that has and the right corresponding policies. And we have here the list of policies. I'll show you in a minute. But before that, I want to show you the NAC VLAN segmentation, which is one option to use with the FortiLink NAC policies. And this NAC VLAN segmentation is basically using one layer 3 interface that is here, the primary interface. This primary interface is holding the layer 3 information, the IP addressing, and then having an onboarding VLAN and multiple other segment VLANs that are going to work or be assigned to the devices that are discovered, and making sure that they have the separation at the layer 2. So we have there the benefit that when a device connects, it will get an IP address, and based on the NAC policies, it will move between segments depending on the conditions that can change over time, but they will still maintain the IP. So that means you don't need to have the need to have any action done on the endpoint side to renew IP address or bounce the port to force the device to change the IP address, to run the DHCP query again. So that is very flexible because you don't know the type of device that is there, what kind of intelligence it has. So it will be very flexible to move that device around on the segments depending on the conditions, and it will still keep the connectivity.
Rafael, so
yes.
the NAC identification, it looks like we're endpoint centric and not user centric. Is that fair? We're profiling a device and not the user using that device.
Yes, I will show you in the policies that it can be based on user as well. Yeah.
Okay. Okay.
So let me show you the policies here. I will show you a simple policy that is based on the MAC address. So in this case, we are matching the first 3 bytes, so the OUI, and then once that is matched, it will be assigned to the VLAN. But we also have, for example, this policy that is matching the hardware vendor and the operating system, no? And then assigning that to a VLAN. But yeah, just go back here to show you. We can also do it by user. So here we can select the user group. So once that user is identified, if it matches that user group, it will be also assigned to the VLAN.
And Rafael, is that user identification, is that happening through like 802.1x authentication, or how are we getting that user ID?
It can be via 802.1x authentication, but also if the endpoint is already discovered somewhere else in the fabric, and that user information is already shared, or if the endpoint is managed by our endpoint management system, that information can also be shared in the fabric and then do the matching. So, and that brings me to the other policy, which is which are these two at the top that are using ZTNA tags. So ZTNA tags are tags that we use for the managed endpoints. So then once that endpoint is matching certain conditions, we can tag it. So in this case, I have a policy. If that endpoint is compliant, we have the tag compliant. That tag is shared within the fabric. So when the endpoint is compliant, it will be assigned a certain VLAN. In this case, the FortiNet. And if for some reason that client has something bad, it needs to be remediated, we can dynamically receive that tag from the endpoint management system and move it to the remediation VLAN in this, as an example, right, to have that endpoint fixed. So just quickly showing the ZTNA tags. So it's part of our ZTNA solution, and they can provided by the endpoint management system that I was mentioning, so the FortiClient EMS, or even by FortiSASE, which is also integrated, right? And FortiSASE that you are going to see in the next demo as well. Okay, so going back to the NAC policy, after we define these policies, we can assign the ports to be in NAC mode. So I will do that in this one as an example. So I'm going to change the mode to NAC. And here I'm going to go to the endpoint. I will enable it. Check that it has got an IP address. Yeah.
You good with that? Yeah, sure.
So here we see the Watson client. So let's go back there and check. So we have a dashboard for NAC devices. So matched NAC devices dashboard. And we see that it is here. So it was matching the policy window and assigned to the OfficeNet. So going back to the policies, now there was a question about 802.1x. So we have also that. So we can use here security policy 802.1x with MAC authentication by PAS as well. And in that case, it's tightly integrated with FortiAuthenticator that was mentioned also. So FortiAuthenticator is used in this case as a radio server, but it could be any radio server as well. But FortiAuthenticator is used here. But what I wanted to show in more depth is the dynamic port policies. These are policies that are applied to the switch port. So it has properties that are assigned to the port. Usually we can do that, and that has very flexible to connect other networking devices. Like we have FortiAP as the wireless access point, or it can be a router, or it can be servers that have virtualization. So you need to have other properties assigned to the port. And in this policy, I'm having two different rules for accepting those devices that are that is one for the FortiAP wireless access point, or for a FortiPhone IP phone. Usually, you have behind the phone you have a computer connected. But yeah, let's check the rule for the FortiAP. So it's using also the device detection and the profiling to identify what is connected. So in this case, it will match device family FortiAP. And then in my example, I'm assigning a different LLDP profile to that port and a VLAN policy. And why this VLAN policy? Because I want to have one VLAN that will be used to manage that FortiAP itself, and other VLANs that will serve those SSIDs deployed there that are bridging to the switch port. So we can already have those VLANs assigned with this policy, right? Because as mentioned before, FortiGate is also the wireless controller, no? So we can control also those access points. And then you see here, we have a matched FortiAP in our topology. We have here, it is connected to switch access to port 24, right? So let's go the port list just to show you here. Access to port 24. We have the port is in assigned port policy mode. The policy is there, and we have here the device information, and we have also the power that is being used by that FortiAP. So it's up via PoE provided by the switch.
Raphael, we have just a couple minutes left. I just wanted to see if there was something you wanted to show to wrap up.
Yes, thank you. Yes, I'd like to go back to the list here of the switches, because so far we were checking the topology, but the list is very useful as well. We can have in one FortiGate up to 300 switches, so we can have very big list here, and we can have big topology. But the list itself can be useful. You can do filtering here to check the health status. Any column here can be filtered, right? And we can easily see if there is anything we need to check in more depth. And then if that's the case, we can open the diagnostics. And just let me close this. Yeah. So diagnostics and tools panel with very detailed information about the switch. So we have at the top the general information about the system, the faceplate. Here we have also the PoE power budget. No? So if there is a need to check how much power is being used. Port health check. So here it's triggering us information about port 24 having errors. No? So we can double click on the port and open the statistics. And in this case, I'm directly going to the issues. So we see you have fragments incrementing, and do the check of those errors. And if we want to monitor also the quantity of data, we can also do that.